Hello and good morning dear students. So welcome back and let's continue with question number 11. Because of the network problem, I was not being able to continue today's class. Question number 11 says that, your question says that if three quantities are in continued proportion, we have taken three quantities, three numbers as x, y, z. X, y and z are in continued proportion, then show that the ratio of first to third, then the ratio of first to third, that is this, is the duplicate ratio of first to second. Okay, if three numbers, if x, y, z are in continued proportion, then prove that the ratio of first to third is the duplicate ratio of first to second. That is the question telling you. So which means that all in all, if x, y, z are in continued proportion, then we are to prove x is to z is equals to x square is to y square. This is what we need to prove. Okay, now as we know that if x, y, z are in continued proportion, x by y is equals to y by z, which means this. And yes, just now we have learned about k method. So x by y is equals to y by z equals to k c. So this will give me x is equals to yk and y is equals to zk, which is this. X equals to yk, y equals to zk. We will be needing these values out here. Okay, the question says that prove that the ratio of first to third, as these are the three numbers, we have to prove that the ratio of first to third, that is x to z, is the duplicate ratio of first to second. Okay, x by z is nothing but we need to prove the duplicate ratio of this. So let's start with LHS. LHS is x by z, x by z. You put the value for x. What is x? Yk. So x by z is equals to yk by z. Again, I know the value for y equals to zk. So putting the value for y, zk into k divided by z, z gets cancelled out and I get k square. This is my left hand side. The right hand side is x square by y square. Please put the value for x square. Please put the value for x. X is yk. So x square will be y square into k square divided by y square. Both gets cancelled out. Again, I left with k square and k square, which means the left hand side equals to right hand side, which means this ratio equals to this, which means x is to z is the duplicate ratio of x is to y. Please pause the video and note it down. Alright boys, let's continue with question number 12. Your question number 12 says that if y is the mean proportion between x and z, then prove that left hand side equals to right hand side. This is equals to this. Okay, so given to us again, y is the mean proportion between x and z. So y is the mean proportion between x and z means x, y and z are in continued proportion. So we know that if x, y, z are in continued proportion, then x by y is equals to y by z is equals to k by k method. Let's see. Okay, therefore x is equals to yk and y equals to zk. This is clear. X is equals to y into k, y is equals to z into k. This is clear to us. Another thing I know x equals to yk, but y equals to zk. So here only I find the value for x. So x is equals to actually what? X is equals to yk actually, but again what is y? Y equals to zk. So if I put the value for y as zk, then I'll be getting zk square. So the value for x is how much? Zk square and y equals to zk. So these two values will put in left hand side. Am I clear? So now we have to prove left hand side equals to right hand side. Okay, so let's write down left hand side, which is this. So LHS is x square minus y square plus z square divided by x to the power minus 2 minus y to the power minus 2 plus z to the power minus 2. Now to the power minus 2 means 1 by x square minus 1 by y square plus 1 by z square. This is clear to everyone. Okay, not a problem. What we'll do now is you put the value for x and y, because I know the value for x and y in both the numerator and denominator. Okay, so you put x equals to zk square. So x is equals to zk square means x square will be z square k to the power 4 minus y equals to zk means z square k square plus z square remains as it is. You just put the value for x, y, okay, and accordingly square is there. Denominator 1 by x square means the same, and then this means this. Okay, from the numerator, boys, what you can take common is z square. Z square you can take common. So if you take z square common within the bracket, you will be getting k to the power 4 minus k square plus 1, which is this. From denominator also, 1 by z square, 1 by z square, 1 by z square you can take common. So therefore within the bracket I'll be getting 1 by k to the power 4 minus 1 by k square plus 1. I hope this is clear to you all. Okay, now see 1 z square, and we have whole divided by 1 by z square. So this 1 by z square will be reciprocal and will go up in the numerator. Z square into z square will be z to the power 4. I hope you are clear with this z to the power 4. This z square into z square. Huh? After that, k to the power 4 minus k square plus 1. Alright, denominator within the bracket, what is my LCM? My LCM is k to the power 4. So k to the power 4 is my LCM. K to the power 4 into 1. So hence it is 1. 1 into 1 is 1 minus k square into k to the power 4 times. Sorry, k square into k square times. So k square into 1 is k square plus this is 1 into k to the power 4. So this is, you know how to do. Okay, the LCM. Now if you see properly, these two are similar. K to the power 4 minus k square plus 1. K to the power 4 minus k square plus 1. So this expression and this gets cancelled out. And what happens to 1 by k to the power 4? It goes up in the numerator. And I will be getting z to the power 4 into k to the power 4 to the power. So therefore, all in all, this is zk whole to the power 4. And what is zk? Zk is nothing but y. What is zk? Zk is y. So hence this is y to the power 4, which is my right hand side. Okay, so in this way, the K method helps us to simplify LHS is equals to RHS in this way. Okay, so please pause the video and note it down. Alright boys, we'll keep this much for today. Now from this exercise, you will do question number 13 and question number 14 as today's assignment. And we'll finish our exercise till number 14. Okay, in the next class we'll study more about proportion, different types of proportion, and then we'll hop on to the next exercise. Please complete today's work, the work which we have done in Google class, and these two sums, and complete this 13-14 as homework and submit it to me by today. Okay, thank you boys.